Hi there. So welcome to the session, and in this session we are looking at QHO 2013. And obviously there's no point telling you the reference to this, but then I thought that because you guys, I have shared the PDF with you, so you guys should in fact be aware of it. Nevertheless, these are the questions. There are 15 questions in this handout. If you want to possibly pause the video right now and take a screenshot, you can do that. There are additional 5 questions here. You can look at that. If you want to take a screenshot, great. There are some color coded questions also. I think these questions will have some value addition to them. Nevertheless, let's start with the session, and I hope I can do as many questions as I can in this one. Let's start with the first one. The first one says find the remainder when 323232 dot 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 up to 300 digits is divided by 99. Now please recall I have taught you this in the classes that this is straight up coming from the fact 10. Hold on, this is straight up coming from the concept of 10 raised to the power n plus or minus 1. Okay, if it is 10 raised to the power plus 1, I'm just gonna revise you a little bit. It will be of the form 11 101 1001 and so on and so forth. If it is of the form 10 raised to the power n minus 1, it will be 9 99 999. Okay, now if you have understood, these are basically going to be the extrapolation of the divisibility rule of 11 and 9 itself. I have very elaborately explained this in the concept classes. So what we will be doing, we will be employing one of the techniques of that. So the first question, 32 32 32 dot 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 32 32. What you need to do in this part is that you need to exactly employ the technique that have been taught to you for the divisibility rule of 9, but because this is not exactly 9, this is 99, we will be modifying the type. In 9 we find the digital sum of single digit. Here we will have to group them, and the groups will happen with the number of n that is present. Here if you realize, this is 10 square minus 1, which is 100. That's why we are grouping it 2 digits at a time. So 2 digits at a time, I've realized that this is 32 plus 32. Okay, so how many digits are what is the sum that I'm getting with these two blocks? Whatever the sum is, okay, that is not important. 64 is the sum, but that sum gets repeated how many times? So how many blocks am I getting? I hope you have understood the idea logically. So the funda now becomes very clear. All I need to do is I need to realize that this is 64 into 75, because 75 blocks will be there, divided by 99 remainder. Okay, I'm just writing it over there. Now 64 into 75, if you do, it's although not a very difficult multiplication, you can do that very easily. Let's do that. Okay, we can employ some Vedic maths technique. 5 4s are 22. This is 30 plus 28, 58 plus 2 is 60. 0 6. 42 plus 6 is 48. Okay, this is 4800. 4800 upon 99 remainder. Now my dear friends, at this point you can actually divide this also, but then again form the two groups and add. So you will get a 48 divided by 99. But hey, wait, 48 happens to be less than the divisor 99, so 48 has to be the answer. Okay, so obviously I explained, so I didn't had a lot of space over here. From the next question onward, I'll try to do everything neatly. Okay, so let's just get some space. Let's look into the next question. Now the next question says that find the remainder when 387 387, and again it is repeating, up to 450 digits divided by 999. Okay, we have to find the remainders. So let's calculate this. So this is 387 dot 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 387 387 387. I'm just writing it for reference. You have understood what I'm about to do. Because this is 999, okay, I'm gonna be making group of 3 digits, group of three digits. Okay, I hope that makes sense. From the right hand side, this is very important. Every time you make the group will be made from the right hand side. This is going to be whatever I don't know at this point. This is going to be, you can do the addition also. This is going to be 14 and 16 1, 17 7 7 4. I hope that makes sense. Now again, 6 digits groups, total number of digits is 450. Do I need to do the calculation? You know for a fact this is going to be again a 75. Okay, 999, the remainder. Okay. Now at this point, what can I do? Is there a shortcut? No, there are no shortcut. You have to do the multiplication, and part of the reason that these questions are provided to you is also so that your multiplication skills also become a little good. So it is a good idea to sit and do the calculation, okay, into 75. So this is 5 4s are 22, 35, 37, 3, 35 and 3, 38. I hope I haven't made any error. Okay, 28 to 49, 51, 5, 49 plus 5 is 64, right? 54. I hope I haven't made any mistakes. So this is 15 1 9 10 7 8 and 58050. Okay, now my dear friends, if there is a teacher or a mentor or a faculty who tells you that there is a method through which I can do this quickly, they're just making you stupid or something. Okay, so this is 58050 divided by 999. And also let me tell you that you will require some time to practice this thing. You will take time to realize. Again, this is a great big enough number. So what will I do? So what I will do is I'll just again make the 3-digit block. So this is 58 plus 50, that is 108, divided by 999. Now just see, I have been employing the same technique, and again my dear friends, 108 is less than the divisor 999, so the answer to this question happens to be a 108. If you do not agree to me, I can show you the answers also. Let's see if I can. Yeah, so these are the answers. Hopefully you can see, you can zoom in at your own perusal. You can also see the solutions, how Time Institute people have explained. If this explanation makes sense to you, great. If not, then you can stick to my methods. Okay, I'll take a couple of more questions because this handout has 15 questions. I do not intend to solve all the 15 questions in this session, but hopefully we will solve the entire one. This one says find the remainder when, now this is a 101, okay, divided by 101. The numbers are 568, 568. Okay, an interesting one. So let's do this. So it's a 5 6 7 8, 5 6 7 8, 5 6 7 8. The 4 digits repeating up to 240 digits. Okay, so that should ring some bells. 5 6 7 8, 5 6 7 8. Now exact same technique, just one thing that you need to pay attention to, that what I will be doing at this time, I am looking at 101. Now 101 happens to be a 10 square plus 1. Does this make sense? Okay, every time I ask you does this make sense, please pause the video. If you can, if you want, you can pause the video and ask yourself. So from the right hand side we will make groups of 2, but please remember this is the divisibility rule of 11. This will take from the divisibility rule of 11. So the divisibility rule of 11 says that we will extend the divisibility rule of 11, which says that we have to find the sum of the alternate digits starting from the unit digits and find the difference of that from the sum of the alternate digits starting from the tens digit. So we will make these our sum, and that summation, whatever the 78 plus 78 is, that I need to subtract from these two numbers. Okay, and if you realize, this also will give you a block of how many numbers? A block of total 4 and 4, 8 numbers. Okay, I'm not in a hurry to explain everything in a jiffy. Okay, if you are looking for something of that sort, you can just maybe go to some other place. I'll explain everything in a more detailed way. So yeah, 78 will come how many times? You can either look at this block as a whole, or you can be a little smart and you can see, because there are total 240 digits, so can you understand that total 67 eights I'll get? Why? Because 7 eighths is a block of 2 digits. Okay, how many single digits will be there, how many double digits will be there, three digits will be there? That is a calculation that you will have to do. So obviously, let me tell you, 78 into something minus 56 into that thing divided by 101. Now let me again caution you that this part is very easy. To fill in the numbers in these brackets is a little difficult one, and I'm not saying, so I will not give you any standalone theory or a formula or a trick. This is, you have to like logically think, because there are two digits, so I will get 60 over there. Okay, if I give you a logic, if I give you a trick, you will make errors. I don't want you to make errors. That is why I'm not giving you any trick. Yeah, but once you establish that 60 is going to be in there, after that what I can do, I can simply do this. If 60 into 78 minus 56 divided by 101 remainder. Okay, now this is 22 if I'm not mistaken. 22 into 6 is 132 and a 0 divided by 101. So what do I do? Again, I can do the division here, but again I'll do the same thing. From the right hand side, I'll make the group. I will not add, I will subtract. From 20, if I subtract 13, I get a 7. And please note that 7 is less than the divisor 101. So my answer will be 7. I hope that made sense. Okay. Let's go to the next question. Okay. Before going to the next question, here is the solution by the institute. You can see the solution. If the solution makes sense to you, great. See, if you pay attention now, one way or the other, even the solution will reach the same stage, 78 minus 56 into 60. Now, this is the time wherein you should ask yourself that if you are facing difficulty in finding the 60, take couple of numbers and practice them. Okay. So let's not waste time. Let's go to the next question. So this is the fourth question now. The fourth question says, find the remainder when this digits. Now this is a big enough digit, so this is 145279, 1452 and 79. This humongous digit is getting repeated up to 900 digits. So let me write it 145279. Let me see if I can fit in one more, 145279. Okay, and I need to find the remainder when this thing gets divided. Okay, 900 digits, 1001. Okay, same logic that I have told you, the divisibility rule of 11, but we need to be cautious. What we need to do over here is that we need to make a group of 3 numbers. Why 3 numbers? Because this is 10 raised to the power 3 plus 1. Always pay attention to this 3. Also, I mean, you can look at the number of zeros also present in the 1000. So 3 digits from the right hand side. I hope that is clear. If you just remember this thing, you will make no errors. So 279, and then again there is a group over there, 279, and a 145. We will find the difference of this. I will again ask you, my dear friend, please pause the video if you really want to learn. If you really want to learn, please pause the video. Please tell me what will you fill in these brackets. Because if I tell you straight out, you will not learn anything. You have to pause the video and you have to tell me. How many digits? The digits are 900 digits. Okay. So, okay, let me say that I don't know. Sir, I want to fill in. So let me use a different color. Wait. So, sir, I want to fill 300. Just look at this thing. There are three digits repeating 300 times. So 279 will become 279, 279, 279 will become 900. That is not possible. So it cannot be 300. So this is how you will neglect your number. So what is it that I can put? Not 300. So 150 I will put, because 150 into the 3 digits will make it a 450 digits. 450, 279, 279, 279, 279, and the next 450 batch will come from these numbers 145, 145, 145. So you will put a 145 there. After you have substituted 150 over there, now it is like, I mean, this is a child's play, right? So this is 279 minus 145 becomes a 134 divided by 1001 remainder. Okay. Now at this point somebody might say, I have a Brahmastra to solve this thing. I don't really think there is any Brahmastra or Varunastra as such. All you need to do is you'll have to diligently do the multiplication of 15 into that 134. 15 4s are 60, 0, 45, and hold on. Okay, so I think even I will make a mistakes if I do orally, so let me do this like this only. So this is going to be 5 4s are 22, 15, 16, 17, 6, 1 4s are 4, 1 3s are 3, 1 1s are 1. I hope I haven't made any error. So this is 11, 20100. So this is going to be 20100 divided by 1001 remainder. Now my dear friends, again this division you can do this division, but at this point I will again reiterate myself couple of times so that you will learn it. Make the group of 3 and then subtract, so this becomes 100 minus 20, that is 80. Okay, 80 by 1001. Please tell me what 80 is less than the divisor, so the answer or the remainder will be 80 itself. Okay, I hope that is clear. Okay, all right, let's go to the next question, shall we? The next question is of a different kind. The next question asks us to find out the remainder when 127 raised to the power 133 gets divided by 67. Okay, now at this point this is Fermat's little theorem. Okay, or you can also say remainder theorem, Fermat's little remainder theorem, which basically translate to, if you want to write this also in your copies, you can write it. Fermat's little theorem basically says that if a number is of the form a raised to the power p minus 1 by p, where a and p are co-prime, okay, then the remainder to this thing happens to be a 1. 66 into let's say 2, so this is 132. I hope that made sense. 66 into 2, 132. This is 127 raised to the power 132 by 67 into 127 by 67. I hope that makes sense. Why is it I'm doing this? These are just for the remainders. Okay, these are not actual multiplication as such. This thing will become 1. This is your Fermat's little theorem. Okay, right now I said that it is equals to 1. That means that whatever the number in the numerator has to be a multiple of 67. Okay, now everything I will get from this part only, 127 only. So 127, let's say this is 132, so we'll just subtract 67 from 127, so that is nothing but a 60. Okay, this is nothing but a 60. So this is the answer to this. I hope you have understood. I'll show you the explanation also if I can. Yeah, so this is the explanation. This explanation using Fermat's little theorem, they have answer is 60. If p is a prime such that a and p are co-prime, then a raised to the power p minus 1 leaves a remainder of 1. So basically exactly what I was telling you. Either it leaves out a remainder of 1, or it's a multiple. Okay, but please understand that there will be cases when you will find the remainder to be 0 also. Okay, that is a special case of Fermat's theorem using the Euler number or the totient function. Okay, I am not saying that you will not get the remainder as 1. It's just that it's a little bit of confusion that comes in whenever you get such type of a question. Also, before moving to the next question, let me also iterate one more thing. There is a very good possibility that I can solve the same question with Euler's expression also, because 67 happens to be a prime. Okay, in that case And in that case I can actually find out the totient of this thing, 67, and then I can proceed with it. If you realize 67 being a prime, the totient number of this 67 will be a 62. Okay, so sorry, not 62, 66, one less than that, one less than that. Okay, so I think I'm reiterating myself too much. So yeah, I hope you've understood what I was trying to tell you, right? So let's go to the next one. So this one says 43 raised to the power 91 divided by 19. Again, 19 happens to be a prime number. So we can use directly the Fermat's theorem, okay, Fermat's little theorem, or I can also do something else. For example, I can actually use basic remainder theorem also to solve this. But then, you know, because we are using the QAHO to revise couple of ideas, so let's use the remainder theorem also only. So again, this is a, let's say, what, this is a prime number 19. So what I will do is I'll try to, you know, find out the number that is 1 less than 19 ka multiple. Basically what I'm trying to say is I need to find out something that, you know, some multiple of 18 that you know, takes me closer to 90. We know 18 fives are 90. Okay, yeah, so let's do that. So this is going to be 43 raised to the power 90 by 19, and there will be one more 43 by 90. Okay, I hope this is clear. I am again reiterating myself, this is not actual multiplication, we are just looking at the remainders. Now this part, by the application of Fermat's little theorem, I know the remainder will be 1. 43 is, you know, less, is not less than 19, it's more than 1. So 19 twos are 38. So 43 minus 38, this is going to be 3 and 5, that is 5, and goes away. So remainder of this thing comes out to be 5. Okay, I mean, see, these are not difficult questions. It's just that how you see or how you modify the question type. If you are hell-bent on using Fermat's little theorem, then you will have to remember the, you know, Fermat's little remainder theorem. Then you will have to remember the idea that every time you'll have to check for one less than the denominator. But at the same time, if you know that this is a prime number, you can directly employ the tactics of the totient number of 19, and you can directly, you would have written this one less than that, because number of primes less than 19 will be 18. I have said a little too much in this questions, but then these are not difficult. That's you know, this is what I am trying to persuade you to, that these are not difficult. We are just looking at this thing, right? Okay, the seventh question now. The seventh question is saying 104 raised to the power 112 divided by 23. If you realize 23 again happens to be a prime number. Okay, now all I need to do is I need to see 23 into sorry, not 23, 22 into what will get me closer to 112. So 22 into 5 is 5 twos are 10 and 11, 110. So I can actually write this thing as 104 raised to the power 110 by 23 remainder multiplied by how many more? 104 the square by 23. Okay, all right. Is there any better way to do this? Okay, well, okay, so this part is 1 by the Fermat's little remainder theorem. This part, the remainder is 1 multiplied by the remainder of this part. Okay, okay, let me see if I have a better method to find out the multiplication of 104 square, because 104 into 104 will be, I mean, I can do the multiplication, but I'm just trying to think of a better, you know, method, if at all there exists one. 23 into something, so 23 into something, 23 into, let's say, 4, 12, and this is 92, because 5 will be more, 5 will be 115, so that will be more, so 4 times I can actually go. So 104 minus 92, this is 2, 12 into 12, wow, So this is exactly what I was looking at. Okay, I'm sorry if I took some time. Okay, extremely sorry for that. But then, even my brain, sometimes freezes. So 12 into 12 is 144 by 23. Again, you just need to find out a number that is preferably closer to 144, right? 23 into something, let's say. Is there any other better method? No, I think we can do this much, right? We can do this much. So 4 will give me this, 5 will give me a 115, 6 will give me how much? 6 will give me 120, and 18, 138. So 6 will give me 138, and 7 will give me more than 140. So exactly how much? 140 plus 21, that is 160 something. So 6 will suffice. So 144 into 144 minus 38. So basically I'll be left with 006. Yeah, I hope this is clear. Yeah, 14 minus 86, and this one 00. Yeah, so the remainder to this question is this thing. The thing is, now I was trying to figure out some decent method that would have helped me eliminate the multiplication of these 3-digit numbers, and that basically came to me. I just replaced these numbers with the remainders that I would have got from 104 and 104. The remainders that I would have got was 12 and 12, and then 12 and 12 is 144, which is more than the divisor 23. In that case, I just multiplied by 23 into 6 is 138. 138 when gets subtracted from 144 gives us 6, which has to be the remainder, ultimate remainder. Okay, now again, it's how I like to, visualize. I'm also not very good with these 3-digit multiplication and all, and I want to escape the 3-digit multiplication. If you like them, I don't have a problem, but yeah, for me I would have skipped them. But yeah, this is how you could have done it. It would have taken, let's say, 1 minute, 2 minutes, but you would have solved it. That's one thing for a fact, that you would have solved it. It may have taken you 2 minutes, 2.5 minutes, 3 minutes, doesn't matter. Okay, so the 7 questions we are done. We will head to the 8th one now. Okay, and hopefully there is the 8th question. Okay, yeah. All right, so let me change the color of the pen. The 8th question says find the remainder when 4 raised to the power 120 is divided by 143. Now here we will employ the Euler's theorem. 143. First thing first, we have to check out for 143. 143, whether it is a prime or not, because the only constraint for Euler's theorem is that you need to check whether A upon B are co-primes or not. 4 is a composite number, so there is no point checking for 4. 143 we'll have to check. Now the nearest square, perfect square number with 143 happens to be a 144, which is a 12 square. 12 square ka perfect 12 square is a 144. So all the number below, all the prime numbers, let me reiterate myself, all the prime numbers below 12, like 12, 11, even excluding 12 also, because 12 is not a prime number. So you could have used 13, but again, you get the point. So 11, 9, 7, 5, 3, 2, 1. We need to check for 143. So 11, if you see 11 say this actually goes. 11 say this goes. Okay, the first number that I check, it goes. Okay, so this is a googly. I thought 143 would have been a this thing, but that's not a problem. So what what is the prime factorization of this? This is 11 into 13. Okay, so we will have to modify the idea of the totient, this thing. So how do we calculate the totient function for 143? Very simple. We write 143 into, I have explained this thing in greater depth in the concept videos. So if you are new to the channel, you can check out the concept videos as well. That is going to be 1 minus 1 by 1 minus 1 by 11, that is 10 by 11, into 1 minus 1 by 13, that is 12 by 13. Now if you pay attention, this and this goes away, so the totient for this comes out to be 120. Now if you pay attention that 4 has been raised to 120 itself, so the remainder or the ultimate remainder to this question will be 1, because it directly follows the Euler's theorem. Okay, we can say Euler's theorem, or we can also say Euler's remainder theorem. Okay, let me show you the answer also if you wish to see the answer. Okay, so this is the answer. I hope you can see the cursor. When successive powers of 4 are divided by 11 and all that, you can take a screenshot, you can possibly pause and see. Okay, I have not used this method, I have used a different method, and I have reached at the same answer, which is remainder is equals to 1. All right, so okay, I would say at this point I will conclude the session. I'll do the part 2 of this session pretty soon if I get at least 5 likes to this video. And if you really enjoy the handout solving sessions, please do notify me that there are handles that you can see in the video as well as in the description. You can get in touch with me through them. Thank you.